Hi, hello, welcome to VHDL Basics. Today we are going to ask ChatGPT to design a Johnson ring counter. So first of all, what is Johnson ring counter? So counter is also known as twisted ring counter. Is the type of shift register circuit that can be used to sequentially cycle through a set of binary values. It is composed of a series of flip-flops connected in circular pattern, where the output of each flip-flop is connected to the input of the next flip-flop in the chain. So this is the circuit diagram of Johnson counter. If you see here, so first flip-flop output will be connected to the second flip-flop. Likewise, all the um, four flip-flops getting the input from the previous flip-flop. So the last flip-flop output will be inverted, and that will be connected to the input of the first flip-flop. This is the difference between the normal ring standard ring counter with respect to the Johnson ring counter. Now I am going to take this code and I will simulate this, and then I will explain with the waveform. This is a 4-bit Johnson counter which was designed by ChatGPT in VHDL. If you see, clock and reset are the input port of this Johnson counter. Q is output port which has 4-bit since this is 4-bit Johnson counter. And with respect to the circuit diagram, if you refer clock same, but instead of reset in circuit diagram we are having clear. So the functionality of the reset and clear here it is same actually. If you see the process line number 17, right, if reset is for asserted, then all the flip-flop output will be cleared and assigned to 0 actually. And if you see the circuit diagram, there first flip-flop output is directly connected to the second flip-flop input, and the second flip-flop output directly assigned as third flip-flop input D, and third flip-flop output key will be directly assigned to the fourth flip-flop input D. And then the output of the fourth flip-flop Q bar will be assigned to the input of the first flip-flop D. But in this code which was generated by ChatGPT, it is having inverted output of the first flip-flop will be connected to the second flip-flop. But in this case, it will generate only two state. So initially, it will be all the four flip-flop will give 0, and then second state will be all the four flip-flop output will be 1, and then again it is inverted. Then it will be 0, like that. 0 1 0 1 0 1 will come here. But as per the Johnson counter, only last flip-flop output should be inverted. So I am changing that code as per that, and I am going to simulate this. For that I am designing the test bench as well, so I will show you the test bench score for Johnson counter. This is the Johnson counter test bench. Here I am generating the clock as 100 megahertz, so it should toggle for each 5 nanosecond. So the clock period will be 10 nanosecond, which is nothing but 100 megahertz clock. In initial begin, right, there I am resetting the Johnson counter by asserting the reset equal to 1 for the first 50 nanosecond. After that I am deasserting the reset in the line number 15. If you see the line number 6 to 9, I am instantiating the Johnson counter here. Now I am going to show you the waveform with respect to this test bench. In that I will show you the truth table as well. If you see, this is truth table of the Johnson ring counter. It starts with 0000, and then it will start with 0001, right, like that. It will be having 8 state. Once this 8th state is completed, again it will come to 0th state. Okay, so if you see here, once it is reaching 1010, sorry, 1000, it is coming back to initial state of 0000. So like that it will be generating these states circularly. This is called Johnson ring counter. Hope you will like this video. Please share and subscribe this channel for more videos.